Okay, so Jerry, I want you to do this question with me, because Emma and Albert they got them correctly. So I think you are also able to get it correctly. Okay, so just to remind you, any question that asks for the average speed or the average rate of the trip, you have to find the total distance, and then you have to find the total time. Okay, and then total distance divided by total time will be your average speed. Okay. Um, yeah. So let's see what a total distance is and what a total time is. Okay. So read the question again. You'll probably have forgotten the question. So Dale travels from city A to B to C and then back to A, right? So A to B to C and to A. Each city is 120 miles from the other two. Then we have a bunch of average rate here. Okay. So notice that the average rate is not just the average rate. It's not just the average of all the average rates here, okay? You cannot do, 60 plus 40 plus 24 and then divided by 3 because you have to find the total distance divided by the total time. Does that make sense? Total distance divided by total time is the average speed. It's not just the average of the averages, okay? So how do you find the total distance here? We'll call
From like the whole trip from city A to city. You're muted.
hello? Yeah,
Yeah.
I thought I was frozen. Okay. Yeah, the total distance. So Jerry, what did you say?
360.
Mm-hmm. He goes from A to B, B to C, and then back to A. So
So 360 miles.
yeah, very good. So 360 miles. And you're gonna find the total time, right? Do we know the time for each part of the travel?
Can you do 360 divided by 60? And then
Exactly, very nice. We have three different parts of the travel, right? So from A to
yeah.
B, the distance, the speed is 60 miles per hour. So we do, um, so the first part from A to B, the distance is only 120, right? And the
So
speed
then
is
we're do 120 divided by 60.
exactly okay. So we
And that
can,
would
mhm,
then yeah, it would be
yeah. So
two.
it'll be better for us to maybe draw a little diagram here. You see, so A to B, B to C, and C back to A. Now, A to B is 120 miles, and the speed is 60 miles per hour. So you divide them, you will see that the time here, so time from A to B, right? That would be 120 divided by 60, so 2 hours. Okay, what about B to C?
It's 120 divided by 40 miles
Good,
per hour.
good.
So 3 hours.
Yeah, so 3 hours. Very nice. What about C to A?
120 divided 120 divided by 24. So 5 hours.
Very nice. Very good. Yes. So for total time, so because there were three different parts of the travel, and for each part of the travel, the average speed is different, right? So we have to divide each part, each distance by their average speed to find the time, and then we add them up to find the total time. Okay, so the total time would be 2 hours, 3 hours, 5 hours. You add them up, it will be 10 hours, right? And
Yeah.
eventually, your average speed will be what?
It
Total
would be 360 divided by 10, so 36.
exactly.
So 36 miles per hour is the total average speed.
Yes, yes, very good. Very nice. Yeah, okay. So just to remind everyone, if you see every speed and if in the question it says someone took a rest, okay, if someone took a rest, the time he spent, taking a rest will also be counted in the total time. Okay, imagine that you are traveling from, say, Vancouver to Calgary, okay, to Alberta. I'm not sure if you guys have ever done a road trip before with your parents. Okay, your parents drive a long way, right? And go on a road trip. Um, it's very common for us to take a rest in between, right? You take a lunch break, or you just need to take a break because if you drive for too long, it can be very tiring, right? So you have to take a break. Then let's say that you take a half an hour break or an hour break. That time will be included in the total travel time. Okay, maybe you spend 8 hours driving, 2 hours resting. Okay, including your lunch and meal. Then the total travel time will be 10 hours. Okay, the total travel time includes the break time. So if you see a question says someone took a break, someone eat a meal, and they spend some time doing that, those time will be counted in the total time. Okay, so always find the total distance divided by the total time. Does that make sense, Terry?
Yeah. Yeah.
Great. The next problem I believe will be 749. 749. Let me see. So this one, Jerry and Albert, and let's see, Emma. Oh, so Emma got it right. Um, but Jerry and Albert, Albert got it wrong. Okay. And also 748. The 748, only Emma. So let's see, Emma. Okay, Emma, this one only you got wrong. So let's have a look. So let's see why. For questions that only one of you guys got wrong, I think you should be able to get it. And I will I'll guide you and let's do it together. Okay. For questions that more than two, say two of you or three of you got wrong, I will explain. Okay. So Emma, this one you didn't do. Could you tell me why? Any reason? Did you understand the question?
Yeah, I just didn't really understand the question of
Okay, which part? You know what density is?
that. No.
Density, 密度。
Okay.
OK， so density 密度啊，OK，so 一个东西的密度就是说密度越大，那它就越重，也就是说在体积不变的情况下，OK，所以你有没有听说过，比如说金子密度很大，说金子特别重嘛，对不对？那比如说都是一个小方块儿，打出来都这么大一个
嗯
物体，那金子的话就会特别特别的重。如果你把它换成空气呢，哎，就特别特别轻，因为空气密度轻嘛，对不对？如果换成比如说汽油呢，哎，那也不算重。换成水呢就会重一点，但油就比水要轻，所以油浮在水上面，这个就是密度的意思啊。OK，density。你看后面它这个单位啊，叫做 pounds per gallon，就这个液体的密度嘛。所以 what it means is that for 1 gallon of the liquid, it weighs 8 pounds。也就是1加仑，加仑的话大概相当于3.78升，你可以大概理解为4升。4升是多大呢？4升就是那个牛奶罐子，家里有没有喝过那个大罐的牛奶啊？去超市见过吧？OK，那种最大罐的牛奶啊，那个就是4升的，那就是1个 gallon，好吧？就那么多液体呢，大概重8磅。它是说这个 liquid A，这个 liquid B 就是 B 这个液体呢，它是每 gallon 重6磅，OK 吧？这就是说了个这个啊。然后题目问的是什么呀？What quantity of liquid B weighs the same as 30 gallons of liquid A？就是如果是，就是说你现在有30加仑 liquid A，跟30加仑 liquid A 一样重的 liquid B 有多少？ 这么个问题，好吧？好，okay, so Emma, I'll guide you, okay? So for liquid A, that's 8 pounds per gallon. 1 gallon, 8 pounds, right? 2 gallon will be 16 pounds. 3 gallon will be 24 pounds. That's what it means, right? So now you have 30 gallons of liquid A, and then you want to find the amount of liquid B that weighs the same as 30 gallons of liquid A. So that means you're going to first find how much does it weigh? How much do 30 gallons of liquid A weigh, right? 你是不是应该先看看30 gallons of liquid A 有多重啊？ Okay, what do you think? How do you find the weight of 30 gallons?
240.
Yeah, just time them, right? To be specific, if you guys remember, we did something called unit conversion. So if you include the unit, it makes a lot more sense. So 30 gallons times for liquid A, that's 8 pounds per gallon. So we say 8 for pounds, we say LB, right? 8 pounds per 1 gallon. You guys remember? Something per something means per one something, right? Miles per hour means 60 miles per 1 hour, per an hour, right? So 8 pounds per gallon, you write something like this down, 8 pounds per 1 gallon. And you time by 30 gallons, you see gallons canceled out. You just have 30 times 8, so 240 pounds. Okay, very nice. So Emma, what's next? So now, so this means that you have 240 pounds of liquid B. And how many gallons would that be? For liquid B, every 6 pounds is a gallon. You have 240 pounds of liquid B. So what about the amount of the liquid? 那么你这么想啊，对于 liquid B，现在是不是它是说 liquid B 跟 liquid A 一样重啊？liquid A 你是不是找到是240磅，right？那么现在就说明你有240磅 liquid B，对吧？喂，Emma，我好像有点卡了。是不是240磅 liquid B 啊？对吧？然后 liquid B 是不是6磅一个 gallon 啊？那它是几个 gallon？240磅
40。
40，对吧？直接除6就行了，对不对？我们还是实际上用 unit conversion，应该是240除以6，对吧？So 为什么是240除以6呢？你看单位就知道，240 pounds。So you say divided by 6. 6 here means 6 pounds per gallon, right? So 6 pounds per 1 gallon. See? So 240 divided by 6, it will become 240 pounds times, and you're gonna, divide it by a fraction, you flip it over, right? So divided by 1 gallon per 6 pounds. You see? So divided by, and pounds canceled, it'll be 240 divided by 6, so 40 gallon. Okay, and the answer just will just be 40.
Okay.
Okay, so that makes sense, Emma?
Yeah.
你看，是个很简单的题，对吧？只是题目没看懂啊。Okay, so density 叫做密度啊，把它记一下。密度呀，比如说像人的密度就比水要小一点，所以人比水就是单位的体积啊，同样的体积是要轻一点，所以人能浮在水上能游泳嘛，对吧？听说过啊？密度啊。Okay, next question. So 749, Jerry and Albert got one, okay, and Emma got it right. So maybe Jerry did one, so Albert, this one is for you, okay? So Albert, the problem with your homework is that if you have it, you can look at it or I can show it here. Let's first read the question and see what you answered there, okay? It says someone's speedometer is broken. He's riding at a constant speed. He times himself and finds that it takes him 1 minute and 20 seconds to ride a mile. how fast is him riding in miles per hour? So Albert is asking how fast is he riding in miles per hour? And let's look at your question, homework. Here, you see, you wrote down 3/4, right? 3/4 minute per mile. But the unit they want is miles per hour, not minute per mile. And minute per mile is not a standard unit, right? Usually we say some miles per minute at least. Miles per minute, not minute per mile. So that's the problem with this, okay? Let's do it again together, okay, Albert? And then let's see how can we do the unit conversion here, okay? So now we know that for every, you could say 80 seconds, right? For every 80 seconds or 1 minute, 20 seconds, he can ride a mile. You want to get miles per hour. So how do you set up your rate here? I'm gonna give you a hint, Albert, okay? Miles per hour, it looks like, let's say 60 miles per hour. There will be 60 miles on top over 1 hour on the bottom, right? So when you set up your fraction or your rate like this, you want to put the distance on the top. Okay, so distance on numerator and time on the denominator. Does that make sense? Distance on top, time on the bottom. Here we have 1 mile and also 1 minute, 20 seconds. So when we set up this rate, do you put mile on top or do you put minutes and seconds on top? Which one is on the top?
We write 1 mile over 80 seconds.
Very nice. Yes, we do 1 mile over 80 seconds. Exactly. Okay, exactly. So 1 minute, 20 seconds will be 80 seconds. We do this rather than the other way around. Okay. Your homework, you did the other way around. You put time on top, you put mile on the bottom. That's why you got, second per mile or minute per mile, something like that. Okay, make sense? But we want mile per minute or per hour. I mean, if you get mile per minute, you just time by 60, you get mile per hour, right? So yeah, divided by 60 now. Yeah, so 1 mile per 80 seconds. Now, I'm just gonna wipe this out. So some miles per 1 hour. So now you have 1 mile per 80 seconds. How do we change it to some mile per hour? So we need to find a way to change this, 80 seconds into an hour thing, right? You remember unit conversion?
Yeah.
Yeah, let's put this down here, okay? So I'm gonna put this one at the very end because we need to time by something, right? Again, unit conversion. So mile, you don't need to change, right? It's still mile. So mile stays the same. Now we need to change second into hour, right? So we first change second into minute. How do we change second into minute?
By putting 80s, by putting the seconds on top and the second and the minutes on the bottom.
Exactly. Okay, so Emma, Jerry, do you guys remember? Okay, Emma got this one correctly. Jerry, does it make sense until now? Okay, you see, you have to put distance on the top and time on bottom, right? I mean, it works both ways. Okay, you can put time on top, doesn't really matter. But the problem is that the question is asking miles per hour, so you have to put distance on top and time on the bottom, because you want to get miles per hour. Because miles per hour is miles on top, hour on the bottom. Okay, Jerry, make sense? So once you write it down, you just do unit conversion. To do unit conversion, just to remind you guys, you want to convert from second to minute, then second on the bottom, so you put second on top, right? So that it can cancel, remember? And then this way you can change it to minute. And you put down the correct number. So 60 seconds per minute. Okay, so see, just after this is called conversion factor, okay? So after this conversion factor, if you time this conversion factor to this fraction, you will get a mile per minute. Okay, Jerry, does that make sense? Yeah, do you recall this kind of stuff? Yeah, that's from the winter this before the winter break. Okay, and then this is only just a minute. We need to change it to an hour. So what do we do?
Minute on top, hour on the bottom, 60 minute over 1 hour.
Very nice. Okay, again, another conversion factor. We cancel out the minutes. We just leave hour here. Yeah. So in the end, we have 1 times 60 times 60 on the top. We could say that's 3,600, and we have 80 on the bottom, right? And eventually we just do a division here. So 360 divided by 8, that's 45. So the answer would be 45 mile per hour. In this case, we just write down mph, a mile per hour. So 45 miles per hour. Okay, Jerry, that makes sense? And Albert, makes sense? So Emma got it right, very nice. Okay, so again, notice that the whole question is pretty logical. Okay, very logical. Because you have miles per hour, so that's why you're gonna do mile per second. Okay, mile on top, second on the bottom. If you do the other way around, you can only get time per mile, right? Like some hour per mile or some minute per mile. And yeah, and that's not what we want. Okay. So make sure you get a correct, you get your rate in the correct order. Okay. Everything is in the correct position. And then you just do conversion factors, and then you can get what you desired. Okay. If there's no question, I'm gonna move on. Next question is 751 here. Seven fifty. Okay, 750 for Jerry. Yeah, 51 for Jerry and Emma. Okay. So, okay, Jerry, your question. This one Emma and Albert got correctly. Okay. So let's see. Elisa swims laps in the pool. When she first started, she completed 10 laps in 25 minutes. Now she can finish 12 laps in 24 minutes. By how many minutes has she improved her lap time? So Jerry, do you understand what lap time means? Is
Like in one lap.
yeah, like how long does it take for her to complete one lap, right? It's the same as running, same
Oh,
as jogging, right?
and I probably read the question wrong.
Oh, okay, yeah. That's why you answer 5 minutes. I mean, that's too much because she can actually complete a lap within 5 minutes, right? So yeah. Lap time means the amount of time she need to take to complete one lap. Okay. So
And
in
can
this,
it be 30 seconds?
yeah, 30 seconds, exactly, half a minute. Yeah. So it's very simple, right? Just find the lap time here and find a lap time here. Just, minute divided by lap, right? Good. And then, so 751, yes, 751. Okay, just give me 1 sec. Okay. 751. I'm gonna delete this. Okay, so this one, Emma and Jerry, then will be Emma's turn, okay? Northbound train from Miami to Jacksonville made 324-mile journey at an average speed 50 miles per hour. Southbound return trip made the journey at an average of 40 miles per hour, and find the average speed. Okay, so another average speed question. So Emma, what do you think? 有没有不理解的地方？Emma，这个题？
基本上很多题没做，就是因为我不太理解题。
我知道很多时候题看不太懂嘛，我知道你，所以就是看你先看题目看懂，给你解释一下哪里没懂。
就是上面那个部分。
上面那个部分，OK，第一句话懂什么？它第一句话这么说啊，northbound 就是往北开，好吧？一个往北开的火车从哪儿开到哪儿呢？从迈阿密开到 Jacksonville，对吧？我也不知道 Jacksonville 在哪儿啊，反正一个城市到另外一个城市嘛，对不对？它往北开，他说 made the journey，就是说完成了这个 journey，对吧？多长的 journey 呢？324 mile。然后速度是多少？他说了，every speed 是50 miles per hour，对不对？OK 吧？他这第一句话就是说啊，这个火车呢从 A 城开到 B 城开了324 mile，然后 every speed 是50 miles per hour。然后呢，他又 return trip，他回来了嘛，southbound 就往南开了，又往南开回来了。开回来呢，那当然同样的 journey，对吧？火车嘛，同样的 journey，对不对？然后它的 every speed 呢变成了40 miles per hour。所以整体来说，它是不是先往北开了324，又往南开了324啊？开过去开回来，是不是一共开了648？所以最后你看他给到648嘛，他说整个 round trip 来回开了648，他问说这个 average speed 是多少？就这么个题啊。OK，and let's all recall that. OK，for every speed you find the total distance, you find the total time, right? Total distance divided by the total time. So it's the same question as 747. Same question as the first one. Okay. So now we have the total distance, right, Emma? It will be just this 648. That's the total distance. What about the total time then? In the first part of the trip, the train goes 324 miles. The speed is 50 miles per hour, right? So what is the time here? Anyone? Or Emma?
324/50.
Yeah, exactly. Okay, if you want to include the unit, you will see that miles and miles cancel out. You just end up with hour. Okay, it's kind of obvious, right? Distance divided by speed is time. That's the first part. Okay, we will calculate this later. What about the time the train spent in the second part of the trip?
324/40.
Exactly. This gives you the total time, right? So when we calculate this, I can use a calculator, but let me just use a calculator. It's not hard to calculate by hand, okay? If you want to calculate by hand, it's not hard either. I mean, what you can do is that it's not that hard, but okay, I'll just do calculate. It will be 14.58 hours. Okay, and to find every speed, we just do what? Total distance and total time, right? We just divide them, correct? So 648 divided by 14.58, okay? 648 divided by that. That will give you 400/9 miles per hour, okay? In the question, it does say to the nearest tenth of a mile per hour, right? It asks you to round to the nearest tenth. So 400/9, that's 44.44444. Okay, so we just say roughly 44.4 miles per hour, roughly. So for roughly, we use a squiggly equal sign, right? Okay, does that make sense, Emma Jerry? Yeah, so for every speed, always make sure you have the total distance and you have a total time. Usually, you see from this question and the first question today, it gives you the total distance easily, usually, okay? And for the total time, you have to do a bunch of division to find out the time, someone spent on each part of the travel, and then you add them up to find the total time. Okay, make sense? That's the technique, the special, you could say the special technique to do this kind of this kind of every speed problem. Okay, every speed problem for the time, usually you have to do a bunch of divisions and add them up. Okay. So next, I think 5, okay, 5, 4. We have 54, 55, 56, and 57, 58. Okay, maybe just these first. Let's see. Emma 55, 57. Okay. All right, 54. 54 is for Jerry. Okay, so 54, Jerry again. Megan has 3 candles of the same length to provide light. Candle A burns for exactly 72 minutes. Candle B burns twice as fast as candle A, and candle C burns 3 times as fast as candle B. What is the greatest total number of minutes of light that all 3 candles can provide? So Jerry, this one, do you understand the question? Any?
Yeah.
Okay. So what do you think? Let's see. Your answer is 648. But think about this. You only have 3 candles, right? The first candle only burns for 72 minutes. The second candle is faster than that. So the second candle wouldn't even burn for this long. And that means 3 candles wouldn't make 648 minutes, right? It would be much less than that. Okay, so let's see. So candle A, we know it can burn for 72 minutes. What about candle B? It burns twice as fast as candle A. So how long do you think candle B can last, can burn? For how many minutes? Candle B can burn for how many minutes? Twice as fast.
36 minutes.
Yeah, 36 minutes, right? It's twice as fast. So you can burn for 36 minutes.
And then
Mhm.
candle C can burn for 12 minutes.
Yeah. So candle C can burn is 3 times as fast, so 12 minutes.
Do you add all of them together for the
Yeah.
final answer?
Yeah, because you
Oh.
want the greatest total number of minutes, right? Of
So
light.
120 minutes, right?
Yeah.
Oh, then I read the question wrong again because when it says burn twice as fast, I used the wrong logic and made it burn slower.
Oh, and you time by 2, right? Okay, I got it. Yeah, it will be that means it burns twice as slower as candle light, right? Burns faster means it ends, it ends faster. Yeah. Okay, very nice. Not a hard question at all. Next, 55. 55, I believe that's Jerry and Emma, I think. So 55, yes. Okay, so this one, Emma. Okay, so Emma, I think this one you can understand. Working alone, Jamie can mow her lawn in 75 minutes. If Bob helps her, then the two can mow the lawn in 30 minutes. How long does it take Bob to mow the lawn alone? I think you understand this, right? Yeah, okay. So yeah, but you didn't do this. Any question for this? So
I just don't know like which way I should do it.
Okay, very good. Okay, so this is a very classic what we call a work rate problem. Okay, so for Jerry and also Albert, I know you got it right, but listen carefully. Maybe something you can pick up. Okay, so Jerry, you want to make a note, and Emma, you want to make a note because for work rate problem is very popular, very popular. Um, I would say it appears on, it appears on like grade 7, grade 8, grade 9 math competition at least once per 2 years, at least. Okay, sometimes it appears every year. Okay, work rate problems are very popular. So for work rate problem, it always tell you it will always tells you a person does a job in how many hours, another person does a job in how many hours or how many minutes. Okay, it will always say someone does a job in some time. Okay, it always give you this. Someone paints the entire wall. Someone builds a house in how many days, in how many minutes, in how many hours. Okay, it will always tell you this. All right, what you need to do is to figure out the rate, the work rate for everyone. Okay, by work rate, I mean that in a specific amount of time, say in 1 minute or in an hour, it really depends on the question, right? In this question, it uses minutes. In other questions, he might use hours, he might use days. What you need to do is to figure out how much of the work can they complete in 1 minute or in 1 hour or in one day. Okay, you're gonna figure out individual work rate. So in this question, let's use it as an example, right? So let's say Jamie. We know that Jamie can mow the lawn in 75 minutes by her alone, right? So in other words, the work rate for Jamie, think about this, is 1/75, 1/75 of the entire lawn, of the entire job in 1 minute. See if that makes sense. It takes Jamie 75 minutes to complete a job, whatever job here is, right? Here is to mow the lawn. In other questions, it could be any other job. Okay, let's just say Jamie does the job in 75 minutes. And that means in 1 minute, she can do 1/75 of the entire job, right? Because 75 minutes, she completes the whole job. There'll be one. She completes everything. That's whole job. That's one, right? That's 100%. Okay. So in 1 minute, she can do 1/75. 2 minutes, there'll be 2/75, right? 3 minutes, that's 3/75. And 75 minutes later, she can complete 75/75 after 75 minutes, right? Because each minute she can complete 1/75. Then for 75 minutes, she can complete 75/75. That means she completes the job. Does that make sense? Jerry, that make sense? Emma, that make sense? OK，一定，我再给你解释一下中文啊，就是这种题啊，这个叫做工作效率题 （work rate），好吧？这一类的题的它的那个 wording 啊，一定都是说一个人干了一件事用了多长时间，时间的单位呢是会有变化的，有些题用的是分钟，有些题用的是小时，有些题用的是天，但是所有的题都会说一个人干一件事儿，不管什么事他会告诉你，对吧？但无所谓嘛，一个人干一件事要多长时间？要多少分钟？要多少小时？要多少天？对于你来说呢，你必须要把每个人的 work rate 弄出来，也就是说，在1分钟，或者说1小时，或者说一天，他能完成整个工作的几分之几。那么这个完成的这个几分之几呢？其实很简单，就是1除以这个 75 minutes，或者是比如说假设是6天，那你一天不就完成1/6吗？如果是15小时完成一个工作，那1小时是不是完成15/1啊？75分钟完成一个工作，1分钟是不是完成75/1啊？是非常好做的嘛。其实1除以时间，明白吗？你把这个要弄出来就可以了。OK，yeah. So for Jerry and Albert, okay, again, if you take say 6 days to complete a job, then for each day you can complete 1/6, right? 1/6 of the job. If it takes you say 15 hours to complete a job, Then for an hour, for 1 hour, you can complete 1 out of 15 of the job, right? Does that make sense? Basically just 1 over that time, right? 1 over the time, it gives you how much of the work you can complete in 1 unit of time. In this case, will be minute. Okay. So after this, and then you basically just need to work out all the work rates provided by the question. Okay. You see that in the second sentence, if Bob helps Jamie, then the two can mow the lawn in 30 minutes, right? So now if we have two people, Bob and Jamie, they can complete a job in 30 minutes. That means in 1 minute, they can complete how much of the job? Anyone? So Emma, Jerry? Two guys working together, they can finish the job in 30 minutes, right? So that means in 1 minute, they can complete how much of the job?
1/30th.
Yeah, 1/30th of the job, right? Emma, does that make sense? 那么明白吧，对不对？你看一个人75分钟搞定了，那这个人是不是1分钟就搞75分之一啊？对吧？如果一起的话，30分钟搞定了，那是不是他们一起1分钟可以完成30分之一啊？这样30分钟搞定了嘛，对不对？Okay, make sense? So from this, then you can figure out the work rate for Bob, right? Because the work rate for Jamie is 1 out of 75 per minute. And the work rate for them working together is 1/30th in a minute. Then you can figure out the work rate for Bob. So work rate for Bob will simply just be the difference between them, right? Because when they work together, it's the combined work rate. It's Jamie's work rate plus Bob's work rate equals to combined work rate, right? So if you just need to get Bob's work rate, it would just be Bob plus Jamie, Bob plus Jamie minus Jamie, right? In other words, it would be 1 out of 30 minus 1 out of 75. See if that makes sense? That's Bob's work rate, right? Okay, Jerry, does that make sense? Combined, their work rate is 1/30th in a minute. Individually, Jamie can complete 1 out of 75 in a minute. So that means for Bob, you just need to do a different. You just need to do the subtraction, right? Find a difference of the work rate, and that difference is Bob's work rate. Does Jerry, that make sense? Okay, yeah. So Emma, does that make sense? 对吧？那么我稍微再解释一下，这种题太常见了啊。就是一起做的话，1分钟做30分之一，对吧？因为30分钟做完嘛。一个人做的时候是75分之一。那他现在就想问 Bob 要花多长时间嘛？就是问 Bob 的 work rate，就是 Bob 1分钟能做多少啊？那一减不就知道了嘛，对不对？这种题特别特别常见啊。Okay, Jerry, this question is very very common. Okay, for any question like this, you do the same analysis that as we have done today. Okay, you list down all the names. Sometimes it will give you 3 people or even 4 people. Okay, so you list down all the people. Sometimes they work together. Sometimes maybe 2 of them or 3 of them work together. Sometimes maybe individuals, they're working individually. Okay, so whatever, you just need to work out a work rate for an individual or maybe for 2 or 3 people. Okay, just list them down. And when you need to find one individual, you can always do a subtraction. Okay, Bob plus Jamie minus Jamie. In this case, this will give you the work rate for Bob. Okay. All right, if that makes sense, let's see, 1/30th minus 1 out of 75. That is, I'm just going to use a calculator to save time, okay? That will just give us 1/50th, 1/50th, okay? 1/50th. So Bob in 1 minute can finish 1/50th of a job. So that means how long does it take for Bob to complete a job?
15 minutes.
Yeah, just 15 minutes, right? Yeah, so Bob takes 50 minutes to mow the lawn. 15 minutes. Okay, Emma, Jerry, that makes sense? Yeah, you do a subtraction 1 out of 50, that's Bob's work rate. And again, in 1 minute, he can do 1/50th. And that means in 15 minutes, he can complete the whole thing. So the answer is 15 minutes. Okay, you will see that in this kind of question, it will always involve 1 over something minus or plus 1 over something. Okay, a variant of this question, a variant, Emma 就是说一个变形啊 ，OK， 这种题的变形。A variant of this question will say, for example, Jamie can mow the lawn in 75 minutes, okay? And then Bob can mow the lawn in 15 minutes. How long does it take for both of them to mow the lawn together? That's a variant, okay? In that question, then you figure out Jamie work rate is 1 out of 75, Bob's work rate is 1 out of 50, and you add them up, right? Because now they're working together. Okay, if from working individually to working together, you find out the work rates and then you add them, and then you can find a combined work rate. Okay, so 1 out of 75 plus 1 out of 70, you will find 1 out of 30, and that means in 30 minutes they can finish the job together by working together. Okay, make sense? Yeah. So Albert, does that make sense? Do you have any question for this?
No.
Good. Work rate problems are very popular. Okay, we will see some other examples later. It will always be this kind of thing. Okay. So next, 756. No, 756. Yes. Is this the one? Albert got wrong. Let's check. Okay. 750. Okay, so Albert, you got okay, you got the next question wrong. Okay, so this one, 756, who got wrong? Let's see. Okay, Jerry, okay. Okay, so Jerry, your question again. Basically someone is doing some currency exchange, right? This kind of question is very practical. Like this time when I came to Thailand, the first thing I do is to exchange some currency. You know, the first thing I came out of the airport, right? Came in the airport, I have to change some currency so that I can pay for my taxi and pay for my visa and stuff. Okay, so let's see. He would like to have 2,000 British pounds for his trip. 12.1 Mexican pesos can be exchanged for $1, and $1 can be exchanged for 0.62 pounds. So to the nearest peso, how many pesos will he need in order to get 2,000 British pounds? The question didn't tell us the relationship between peso and pounds, right? It only says peso to dollar and dollar to pounds. So let's see. How many dollars do we need to get 2,000 pounds? So Jerry, this one is for you. You got it wrong. So we could write something down like this. We know that $1 is 0.62 pounds, right? So you can first write this down. $1 is 0.62 pounds. So to get to 2,000 pounds, how many dollars do you need? So Jerry, you can think about this. $1 is 0.62 pounds, right? So how many dollars do you need to get 2,000 pounds, if you have any idea here?
2,000 divided by 0.62 pounds.
Very nice. Yes. There were two ways to think about this. One is to use the conversion factor that we learned previously, okay? Another way to think about this is, is that you can always think, how do we get from 0.62 to 2,000, right? 0.62 to 2000, you have to time by 2000 over 0.62, right? You cancel out the denominator and you get to the numerator, right? So we will see that if you time by 2000 divided by 0.62, you can change from this number to 2000, right? So that means on the other side of the equation, you also want to time by 2000 over 0.62. Okay, so Jerry, I know you got it right, okay, but you are not very sure. I'm just telling you how to make sure that you are doing the correct equation. You see, does that make sense? Because you want to change from this number to this number, right? You want to change from 0.62 to 2000. How do you go from 0.62 to 2000? You divide it by itself first, right? Any number divided by itself is 1, and you time by 2000, you get to 2000. Okay, which means that on the right-hand side, so this is from an equation to another equation, right? From equation to equation, you can time by a number. So you can imagine that on the right-hand side, if you time by 2000 over 0.62, then they will cancel. You will get 2000 pounds. Then on the left-hand side, you're also gonna time by the same number. Okay, or you can always use the conversion factor, right, Jerry? Okay, so for conversion factors, you can just say 2000 pounds. This is what we learned before, right? 2000 pounds, you time by, since you have pounds, you want to change to dollars. So dollar on the top, right? Dollars on top, pounds on bottom. So you can cancel out pounds. And we know that $1 is 0.62 pounds. See, that again, it gives you 2000 divided by 0.62. Okay, Jerry, that makes sense? I wish you can understand both ways, but at least you have to remember this way, okay? Because this is in math 9, math 8, something like that, okay? You will have to do the same thing in math 8 or 9 when you learn about unit conversion. Okay, this is called conversion factor, okay? Match the units, top and bottom, cancel out, and convert to the new units, okay? So this will give us, let's see, 2000. For this kind of question, you can use a calculator. It's 322.5.06, let's say 81, okay, dollars. Okay, and next thing, we need to convert from dollars to pesos, right? We have 12.1 pesos for $1. And now you have this many dollars. So we do a unit conversion again. We put this here, this many dollars times by a fraction, right? Times by a conversion factor. So Jerry, in this conversion factor, what is the unit on top and the unit on the bottom? We want to get from dollars to pesos, okay? So what is the unit on the top and what is the unit on the bottom? Peso.
The unit on top should be pounds, and then the bottom should be dollars.
Yeah, bottom should be dollars. That's very nice because you want to cancel out dollars, right? Now, what is unit on the top? You said pounds. But we want to get pesos, right? So what is the unit on top if you want to get pesos instead of instead of pounds?
Pesos.
Pesos, right? On the top should get pesos, okay? So Jerry, if you put pounds on top, right? Then after dollars are canceled, you just get back to pounds. You actually go back to pounds. You will go back to 2000 pounds. Okay, so you have to put pesos on top because you want pesos. Okay, does that make sense, Emma? And Albert, right? Albert, I know I got it right. Just use conversion factors. So Jerry, that makes sense? From pounds to dollars, you match the pounds, you put dollars on top so that you get dollars. And then from dollars to pesos, the conversion factor should be pesos over dollars because this way can allow you to cancel out the dollars and then you have pesos in the end, okay? And then you fill in the number. The number is 12.1, right? So 12 0.1 peso for $1. So in the end, it will just be this number times 12.1. So 12 times 12.1, that's 39032 pesos, around point something. Okay, so Jerry, that makes sense? And this will be the answer. Okay, Albert, Emma, that makes sense? All these conversion factors. So Emma and Albert, both of your answers are 39035. Okay, Emma and Albert, both of your answers are 39035, but actually it should be 39032. The reason why you guys' answers are a little bit off from the correct answer here is that here you round it up, right? In your calculator, when you do 2000 divided by 0.62, you don't have to, I mean, yeah, for the answer, you can round it up, but in your calculator, it can store this value, right? So in your calculator, you can just, in your calculator, you just need to type this. I want to show you. So this number, 3,222.81, this answer is actually just 2,000 divided by 0.62, right? So instead of using this number, you should actually just use 2,000 over 0.62 so that you don't have any round off from here. So you don't have any incorrect value, because although this value is pretty close to the real value, but it's not a real value, right? It's not an exact value. So in your calculator, you don't have to type in 3,200 something times 12.1. You should just use 2,000 divided by 0.62 times 12.1, right? So in your calculator, you just type in 20000 and then divided by 0.62 and then times 12.1, and that will give you the exact value, like a more accurate value. Okay, yeah. 所以 Emma、Albert 啊，你们这个答案就是 Emma，我给你解释一下，差一点点，就是因为这个地方你 round off 了，你这里 round off 再乘一遍，你就会最后有点差错，知道吧？有点误差。为了避免误差呢，直接就打2000除以0.62嘛，因为本来这个数是2000除以0.62来的，直接在计算器里打2000除以0.62乘以12.1，这样能得到一个更精准的值。好吧，就记住这个事情啊。尽量不要在计算的过程中去 round off，OK，to round off 啊，所以呢，有计算器就可以直接算出来了。Okay, next 7.57. This one is for Albert. Let me see. Okay, this one I think so Jerry got it right. Yeah, Jerry got it right. Albert, you got it wrong. And then let's see, Emma didn't get it either. Okay, so I'll give this chance to Albert to maybe do it again. Okay, so 4 short order cooks can make 24 omelets in 10 minutes. If a diner gets a to-go order for 90 omelets that needs to be ready in 15 minutes, then how many cooks do they need to complete the order on time? Okay, again, a work rate problem. Okay, this kind of work rate problem, you have to figure out, just like the previous problem here, Jamie and Bob, you have to figure out a work rate for an individual. Okay, here is not an individual. This is a group of cooks, right? 4 cooks. So what about one cook? What about one cook in 1 minute? You figure out the individual work rate, then you can figure out how many cooks you need. Okay, so if this is the first time you solve this kind of problem, maybe it is better to make some notes. Okay, you can say, so 4 cooks with 10 minutes can do 24 omelets, right? So list them down. So first we can think, what about only one cook? So the first step, we just bring this down to one, okay? One cook, and everything else is the same. So one cook, because you need the individual work rate, okay? Because in the end, you need to figure out how many cooks you need, right? So let's first figure out for one cook, just one guy. One guy can make an omelet in how many minutes, okay? So one cook, 10 minutes, how many omelets can he make? And Albert?
6.
Just divided by 4, right? Very good. So there's 6 omelets. So Emma, Jerry, that makes sense. Jerry, you got it right. Yeah, Emma, does that make sense? Right? First, bring it down to 1, okay? And then the second step is to bring the minute down to 1 too, okay? 1 minute. So now we can figure out, what about one cook in 1 minute? How many omelets can he make? Albert?
6 divided by 10.
Yes, it's just 6 divided by 10, right? 10 minutes, he can make 6 omelets. So in 1 minute, he can only do 6 out of 10, which is 3 out of 5 omelet. Okay, this is what I meant by finding the individual work rate. In this case, not only do we need to find the individual work rate, but also we need to find the individual work rate in 1 unit of time. One cook in 1 minute can make this many omelets. Okay, and what do we need? We need 90 omelets in 15 minutes, right? We have 15 minutes, and then we need to make 90 omelets. Okay, we know that one cook in 1 minute can make 3 out of 5 omelets, right? So now first, notice that we have 15 minutes. Okay, so think about this. If we only have one cook, only one guy, in 15 minutes, how many omelets can he make? One cook in 1 minute can make 3 out of 5 omelets. What about 15 minutes? 10 minutes, he can make 6, right? What about 15 minutes?
He
Albert?
can make 9 omelets.
What's that?
He can make 9 omelets.
9 omelets. Very nice. Okay, so Emma, Jerry, see if that makes sense? One cook in 10 minutes can make 6 omelets. In other words, you could say 5 minutes, 3 omelets, right? 3 omelets per 5 minutes, or 3 out of 5 omelets per 1 minute. So in 15 minutes, you time by 15. It's kind of logical, right? Emma, Jerry, right? In 1 minute, he can make this many omelets. In 15 minutes, you just time by 15, right? Just 3 out of 5 times 15 equals 9 omelets, right? So one cook in 15 minutes can make 9 omelets. Now you need to make 90 omelets, remember? Right? You have 90 omelets. You should only have 15 minutes. So how many cooks do you need? How do you get from 9 to 90?
We need 10 cooks.
10 cooks. Very nice. So from 9 to 90, one person in 15 minutes can make 9. You need 90, so you need 10 people, 10 cooks. And now that's how we figure it out. Okay, so Emma, that makes sense now? Yeah. This kind of question is also a work rate problem. Okay, it just includes people and time. Okay, so my suggestion for this kind of question is that you always write down how many people, how long, and the workload. Okay, write this down and bring everything down to 1. Okay, down to 1 person, down to 1 minute or 1 hour or 1 day. Okay, other question they could say, 5 people can build something, can build a shack in 15 days. You might say this, right? 5 people, 15 days can build a shack, build a hut, build a building, okay, a small house, okay. And they will ask, say, what about we have 20 people, and how many days can we build a hut? Something like this, right? So you always need to figure out one person in 1 day, one person in 1 minute, one person in 1 hour can do something, and then you just need to see like what is restraint they have, right? They might give you the number of people. The question might give you the amount of time or the total workload. Okay, so based on the conditions given, you can figure out the unknown number by doing simply by doing some division multiplication. Okay, when to use division and when to use multiplication is kind of just practical, just common sense, right? So when you bring it down, you divide. When you make it, when you make the number bigger, you're gonna do multiply. Okay, I hope that makes sense, Albert. Yeah. So you are trying to get an equation there. It's kind of hard. Okay. Honestly, I don't think this kind of question, if you get some equations down, it's actually pretty hard. So it would be better just to write down a list. Okay. Yeah. So Emma, that makes sense? 啊，这种题一定列张表，写下几个人、多长时间干了什么事儿，全部列出来，好白吗？然后呢，全部做除法，5个人就除5，然后15天就除15，全部除完，你就知道一个人在一个单位时间，比如说是1分钟或者1小时或者1天干了啥事儿。最后再看题目他问的啥，他要干多少事儿，或者题目说你先有几个人，或者题目说有个时间限制，怎么样，题目会告诉你的。然后问你说能干啥能干啥，你就把那个对应的数字乘出来就可以了。好吧。Okay, that'll be all for today. So for next week, we will continue to review these problems. And since you guys have finished chapter 7, try to preview chapter 8. Just preview chapter 8.1 if you have time, 8.2. Emma has previewed 8.1, so Emma, you can do 8.2. Okay, Jerry, Albert, do 8.1, and if you have time, maybe do some 8.2 as well. Okay, so next week we will finish chapter 7, I believe, and then the next week we can start chapter 8. Okay, yeah, I'll see you guys next week. Thank you.